Okay, good evening, students. I hope I'm audible. If some of you could just let me know whether I'm audible. Okay, so okay. Just let me see. Acha, okay, not audible. Harsh says I'm audible. I am audible now. Yes, I am. Okay. So, very good evening to all of you, and as you all are preparing for this your computer science examination tomorrow, I would just like to have a short revision because you have been away from yes away from your studies of computer since quite around 2 weeks. So that's why I thought that it is better to have a revision of the curriculum so that you are well aware and prepared for the examination. Now, talking about the syllabus, as you all have been doing and you have already studied, we have basic things which we will be talking about. That is our, first of all, the Boolean algebra, then your propositions, logic gates, application of logic gates, and then Java. This is our syllabus for the first terminal examination, right? Boolean algebra. One more important thing, that's the number system. Right? So these all things you have to be ready with for talking about the curriculum when we talk about. So we'll be discussing all these things in brief. Now, when we talk about this number system, as you already know, number system basically we will be talking about, or you will be getting the conversions, the basic conversions when we talk about the decimal number system, the binary, decimal, octal, and hexadecimal, right? Decimal, binary, octal, and hexadecimal. So these conversions will be there. Basically, a short recap if we do. Now, decimal to binary, when we talk about, for example, I have 175. This is in decimal and it is to be converted to binary, right? 175 is in decimal and it is to be converted to binary. 175 we divide by 2, 287 1, 243 1, 221 1, 210 1, 250 2, 1, and 0. So when we convert this 175 to binary, it comes like this. So we have 1, 0, 1, 0, 1 1 1 1. So this is the decimal to binary conversion. We can directly convert a decimal number to binary number. Now, if I have to convert a binary to decimal, for example, if I have 1011, this is in binary and I have to convert it to decimal, right? A binary number has to be converted to decimal. Now, in this case, if I have 0 1 2 3, right? What I can do? I start from here. 1 into 2 to the power 3 plus 0 into 2 to the power 2. 0 into any number is 0, so I leave it. 1 into 2 to the power 1 plus 1 into 2 to the power 0. 2 to the power 3 is 8 plus 2 to the power 1 is 2. 2. 2 to the power 0 is 1. So 8 plus 2, 10 plus 1, 11. So we can convert this decimal to binary, binary to decimal, right? Decimal to binary and binary to decimal should not be a problem, right? So this is clear, decimal to binary and binary to decimal. Now let's talk about octal. What is an octal number system? An octal number system is a number which has a base of 8. For example, if I have 179, this is in decimal, this has to be converted to octal. For octal, what we do? We divide by 8. 179, I divide by 8. 22, remainder is 3, 8, 2, and 6. So it becomes 263 with a base of 8. 263 with a base of 8. That's the octal number. Again, for example, if I have this 263, this was in octal, this was to be converted to decimal. What we can do? 263, again 0, 1, 2. 2 into 8 to the power 2 plus 6 into 8 to the power 1 plus 3 into 8 to the power 0. 8 to the power 2 is 64 plus 8 to the power 1 is 8. 8 into 6 is 48 plus 8 to the power 0 is 1. 3 into 1 is 3. 1 second. 8 to the power 0, 1, 2. Mistake I did somewhere. 22 is 3, 2, 6. Okay, 2, 6, 3. 3 into 8 to the power 0 is 1. 6 into 8 to the power 1 is 8. 48 is 64. 64. Okay, sorry. This is 8 8 is 64 into 2 is 128. So 128 plus 48 is 176 plus 3 is 179. So this comes 179. Right? So this is decimal to binary, binary to decimal, decimal to octal, octal to decimal. Now, if I have to convert this octal to binary, right? If I have to convert this octal to binary, so as I have told you all earlier, also we have this 4-2-1 rule, right? ABC 4 times 0, 4 times 1. 2 times 0, 2 times 1. 2 times 0, 2 times 1. Then 0, 1, 0, 1, 0, 1, 0, 1. This is 0, this is 1, this is 1, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. 0 to 7, right? 0, 1, 2, 3, 4, 5, 6, 7. Now, for example, if I have 235, 235 is in decimal octal, I have to convert to binary. Right? 235 is in octal, I have to convert in binary. For 2, it is 0, 1, 0. For 3, it is 0, 1, 1. For 5, it is 1, 0, 1. We can exclude this. So this is the binary equivalent. 235 in octal will be written as 1, 0, 0, 1, 1, 1, 0, 1. That will be the binary equivalent. Now, if I have to convert, for example, there is a binary number 1 1 0 1 0 0 1 0. Now, I have to convert it to octal. I make groups of 3. Yes. Now, here I am only 2, so I will put a 0. Now, 0 1 1. This is 3. 0 1 0. It is 2. 0 1 0 is 2. So, this is 3 2 2 in octal. So this way we can convert a decimal number to octal number. So decimal to octal, octal to decimal, binary to octal, octal to binary. These are the conversions which you will get from the octal number system. Then again, when we talk about hexadecimal, for hexadecimal, what we do, if I have 293, I have to convert it to hexadecimal. 16 1 ja 16. I have here 133. 133. 16 8 ja 128. 16 8 ja 128, and this is 5. 1. So this will be 1 2 5 with a hexadecimal value. For example, if I say I have 102, right? 102. Now, if I say here 16 5 ja 90, 16 5 ja 80, 16 6 ja 96. No. Let me change the number. I'm taking 100. 108. 16 6 are 96, remainder is 12, right? Now this is 6 and 12, right? 108 is in decimal. I have to convert it to hexadecimal. Now 16 6 are 96 here, and again remainder is 12. 12 stands for 10 11 12. It is A B C. So it will be 6C. That will be the hexadecimal equivalent. And now if I convert this hexadecimal to decimal, 6C is in hexadecimal, I have to convert, so it is 0 and this is 1. Now 6 into 16 to the power 1 plus C is our 12. 12 into 16 to the power 0. 16 6 are 96 plus 16 to the power 0 is 1. 12 into 61, 12 plus 12, so it is 12. This is 108. So decimal to hexadecimal, hexadecimal to decimal also you can do. So this is about the number systems, basic number system is when we talk about. So this is the conversion decimal to binary, binary to octal, octal to hexadecimal, and all other conversions that you can do easily using this logic. So I hope till this number system part is okay to everyone. No queries should be there in the number system. Anyone has some doubts, you can let me know. You can type in the chat, we can discuss if you have any doubts in the number system part. No doubts? Fine. Then again, you can just check once your binary addition, subtraction, division, multiplication, and addition, subtraction, multiplication, and division in the binary that you can discuss, that you can revise once that part could be done. So when we talk about addition, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and again 1 plus 1 is 0 with a carry of 1. That is about this addition, subtraction, addition part. Subtraction, when I say 0 minus 0 is 0, 1 minus 0 is 1, and 1 minus 1 is 0, and 0 minus 1 is 1 with a borrow of 1. In case of multiplication, when we do multiplication, when we multiply the terms, when you multiply by 1, it remains the same value. When you divide again, it subtract this. It is subtracted. For example, I'll just do one find division for this addition, subtraction, multiplication, and division. You just see here. If I have 101,101 plus 110,101. Now 110 with a carry of 1. This is 1, 1, 1 again 0, carry 1. 1, 1, 0, carry 1, 0 plus 0 is 0. 1 plus 0 is 1, 1 plus 1 is 0, carry 1. 1 plus 1 is 0, carry 1, 0 plus 1 is 1. So this is the addition part. When we talk about subtraction, for example, if I say 1, 1, 0, 0, 1, 0. 1, 0, 1, 0, 1, minus 0 minus 1 is 1 with a borrow of 1. 1 minus 0 is 1, 1 minus 1 is 0. 0 minus 1 is 1, borrow of 1. 0 minus 0, 0, 0 minus 1 is 1. Again, 1 minus 1, 0, borrow is 1, so it is 1. 1 minus 0, 1, 0. So this is the subtraction. Again, if we talk about multiplication, multiplication when we go, for example, if I say 10101 multiplied by 101, if it is 1, 1 0 1 0 1. Again 0. So 0 0 0 0 0. Again 1 0 1 0 1. 1 0 0 1 0 1 and 1. So this is the multiplication. When we talk about, so please do explain one question of PV then. Okay, I'm doing right. So multiplication, I hope it is clear to everyone. Good. So whatever doubts you want me to take up, you can just put in the chat. I'll be taking note of that. Now if I say 1 1 1 0 1 0 1 divided by 1 0 1. Now it goes one time 1 0 1. I subtracted 1 minus 1 is 0, 1 minus 0 is 1, 1 minus 1 is 0. Now comes 0. It will be going 0 times. Then it comes 1. It will go 1 times 1 0 1. 1 minus 1 0, 0 minus 0 is 0, 0 minus 1 is 1 with a borrow 1, so it is 0. Right? Now comes 0. It will go 1 times, so it is 1 0 1. 0 minus 1 1 with a borrow 1. 0 minus 1 is 1 with a borrow of 1. 0 minus 1 1 with a borrow 1, and 1 minus 1 is 0. 1 minus 1 is 0. This is there. Again comes 1. It will go 1 times 1 0 1. 1 minus 1 0. 1 minus 0 1. 1 minus 1 0. So this is it. So the quotient is 1 0 1 1 1. The remainder is 1. Is it clear? Jenny. Okay, so this was all from the number system part, convergence, and again this binary arithmetic. Now, so this was one portion that will give you the basics here. Next, we talk about logic gates. Logic gates, when we talk, logic gates are the building blocks of the digital circuit, right? And when we talk about logic gates, so logic gates, you need to understand this thing that we have three categories: the basic gates, then we have the universal gates, and then we have got the exclusive gates. Now, in the category of basic gates, we have and, or, and not. In universal gates, we have NAND and NOR. In exclusive gates, we have XOR and XNOR. Right? So these are the three categories of the logic gates: and, or, and not. They are in the basic gates. Universal, we have NAND and NOR. And exclusive gates, we have XOR and XNOR. Now, when we talk about this basic gates, right, and, or, and not. Now, when we talk about AND gate, what happens? AND gate, this gives a high output when all the inputs are high, right? The AND gate gives a high output when all inputs are high. The symbol of a AND gate is like this: AND, right? Y equal to A dot B. A dot B. And what happens if I talk about the truth table? How is the truth table? A, B, and Y. 0 0 is 0, 0 1 is 0, 1 0 is 0, 1 1 is 1. This is the AND gate. This AND gate returns a high value when all the inputs are high. OR gate. OR gate, what happens? OR gate, the symbol is like this: Y is equal to A plus B. Right? In this, what happens? 0 0 0 0 1 1 1 0 1 1 1 1. So the OR gate gives a high output when either of the inputs is high. Even if one input is high, the output will be considered as high. Next, we talk about NOT gate. NOT gate, what happens? Y is equal to A bar, right? Y equal to A bar. This is A and this is Y. If 0, then it returns 1. If 1, then it returns 0. This is AND gate, NOT gate. And, OR, and NOT, these are the three basic gates. Next, when we talk about NAND gate, what happens to the NAND gate is just the complement of the AND gate, right? The NAND gate is the complement of. So to obtain, this is the symbol of NAND gate. How do we obtain it? If the output of AND gate, right? This is the output of AND gate. When it is passed through a NOT gate, the final output which we get, that is the output of NAND gate, right? The complement, NAND gate is the complement of AND gate. So 0, 0, 0 or 1. 0, 0 was 0. So it is 1. 0, 1, 0. So it is 1. 1, 0. It is 1. And 1, 1. It is 0. So this is the truth table of NAND gate. Now when we talk about NOR gate, what is the NOR gate? This is the NOR gate. Complement of OR, right? So what we do? We take the OR gate, we pass the output to a NOT gate. The final output which we get, that is the output of a NOR gate. So here what happens? 0, 0, it will be 1, 0, 1, 0, 1, 0, 0, 1, 1, 0. This is the output of a NOR gate. Then when we talk about XOR gate, XOR and XNOR, they are the basically exclusive gates. Why they are known as exclusive gates? Because these gates are formed using the combination of the three basic gates, right? So if I talk about XOR, the XOR gate is represented like this. Y equal to A XOR B. Y equal to A XOR B, right? Y. Now what will happen? This is A, this is B, and this is Y. 0, 0, 0, 1, 1, 0, 1, 1. This gets a high output when odd number of inputs are high. So 0, 0 is 0, 0, 1 is 1, 1, 0 is 1, and 1, 1 is 0. Internally it is A bar B plus A B bar. Right? Then I have the XNOR gate. XNOR. This is XNOR. Y is equal to A XNOR B. So if I say A, B, and Y, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 1. Internally it is AB plus A bar B bar. Right? So this gives a high output when even number of inputs are high. In that case, the XNOR gate gives high output. So this screen, it will give you the complete logic about all the logic gates, right? So this screen, you can take an image of that. This gives the basic information about all the logic gates and or not, NAND, not, XOR, and XNOR. So you can keep it and preserve it for your reference. The entire logic gates are present in that screen, right? So any queries in the logic gates, anyone, if you could have, you just let me know. You can type in the chat. I'll respond it as well. Okay, no doubts. Okay, very good. Now, one thing when I talk about, I'm having it. If you need, you can go to the previous part and then you can take a screenshot of it. Now, when we talk about this NAND and NOR gates, NAND and NOR gates, they are known as universal gates. Why are they known as universal gates? Because using the NAND and NOR gates, we can take an output of any out. Yes, there is any out. Using the NAND and NOR gate, we can. Okay, very good. You knew what I'm going to tell. So using the NAND and NOR gate, we can get the output of any other gate. That's why the NAND and NOR gates are known as. Okay, I have out in this topic. Very good. I'm going to take up that only. So NAND as AND, right? NAND as AND means using NAND gate, how will we get the output of AND gate? Right? Now, this is the NAND gate. I divide the output into two parts, pass it through other NAND gate. The final output which will come, that will be the output of AND gate. So this is NAND as AND. If you want to use the NAND gate as OR gate, what I do, this is the here. I take A, divide it into two parts, pass it through a NAND gate. I take this B, divide it into two parts, pass it through a NAND gate. Take the 2, pass it through a third NAND gate. The final output which you will get, that will be the output of OR gate. If you want to use NAND as NOT, NAND as NOT. Take this, divide into two parts, pass it through another NAND gate. The final output will be NOT. Right? So this is using NAND in different types of gates. NAND as AND, NAND as OR, NAND as NOT. Now, if I say NOT, NOR as OR, take this 2, divide into 2, pass it through another NOR gate. This will be NOR as OR. If you want NOR as NOT, this divide into two parts, pass it through one, second one, divide into 2, then pass this into a third NOR gate. Sorry, this is NOR as AND. Right? If you want to use the NOR gate as NOT, NOR as NOT, take this, divide into two parts, pass it through a NOR gate. This is NOR as NOT. So, since these gates can be used to get obtain the output of any other gate, that's why they are known as universal gates. Any other queries? Let me know related to the gates. Okay. So now, since you are clear till here, you will be able to draw any logic gate, right? If I give a Boolean expression, you should be able to draw any gate from the entire logic circuit for that. For example, if I say A bar B C plus A B bar C plus A B C bar, right? We have to draw the logic circuit for that. You can do it in different ways. I can also do like this. I took this 3 A B C, A bar B C, A bar, then B, and then C, and B. Then A B bar C. This is A. Third is A B C bar. A. And this 3 will be passing through a OR gate. Okay. So this will be logic circuit. You can get a question where you have been given a Boolean expression and you will be asked to draw the logic circuit. Right. So this part could be done. Okay. This is clear. So once you are done with this, right? Once you are done with it, then that is the part which is there in Boolean expression, the logic circuits and all. Then you will be getting again questions when we talk about from K-map, right? K-map you will be getting SOP and POS, and reducing the expressions using K-map, that you will get when how you can reduce the Boolean expressions. How can you do it using K-map? So that is also an important part where you can be asked how to make a K-map, how to reduce, which chapters are coming. Whichever chapters have been taught, they are coming. Right. So when we talk about the K-map, again you need to learn how to reduce the Boolean expression using K-map. That part will be giving you because marks, because you will be able to understand what is the way to reduce the Boolean expression. Like if I say, for example, if I consider a question to solve or reduce a Boolean expression, if I say if I have f a b c d equal to sigma 1, 3, 4, 6, 9, 11, 12, 13, right? 1, 3, 4, 6, 9, 11, 12, 13. Now, if I have to solve it, I'll how do we write a bar, b bar, a bar, b, a b, and a b bar, c bar, d bar, c bar, d, c d, and c d bar. This is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, 8, 9, 10, 11, 12, 13, 14, 15. Now it is 1, 3, 4, 6, 1, 3, 4, 6, 9, 11, 12, 13. Right? Now, if I have to reduce this using K-map, what we will do, we will make groups. What we can do here, I can make a quad like this. I will make a pair like this. I can make a rolling pair like this. I can make a pair like this. Right? So we can say quad between rolling quad between 1, 3, 9, and 11. So this will be what? A bar cancels. So I'm left with B bar, and here I'm left with D. Again, a pair between 4 and 12. This again, A bar cancel each other. This is B, and here C bar, D bar. So this is equal to B, C bar, D bar. If I talk about this pair, a pair between 12 and 13. So this will be A, B, and again C bar. A, B, C bar. And again I have a rolling pair between 4 and 6. You need to show the groups and the highest one first. So it will be A bar, B, and again C bar cancel D bar. A bar, B, D bar. So we will have final F is equal to B bar D plus B C bar D bar plus A B C bar plus A bar B D bar. Right? So this is the way we can get the values, right? This is the way we can get the reduced, and after that you will need to draw the logic circuit of the same. So this is the way we will solve. But this will be from, as I have told, from your first term till the class 12 board examination, you will be getting questions from this. So this was one SOP, right? It's an SOP question. I hope this is clear. Clear. Using NOR gates only we did now. NAND as and NOR as or. So I hope this is clear to everyone. Okay. Next we will do a question from POS. Well, For example, I get a question. This is f a b c d equal to pi 0, 2, 3, 4, 6, 8, 9, 10, 12, 14, 15. 0, 2, 3, 4, 6, 8, 10, 12, 14, 15. Now this one we have to draw. Yeah, so now when we have to solve this, we'll again make the table like this only. This will change a bit the arranging of the elements. Now a bar b bar, so it becomes a plus b. Then again a bar b bar, a bar b, so it is a plus b bar. A b, so it is a bar plus b bar, right? And then a bar plus b. This side it is c plus d, c plus d bar, c bar plus d bar, and c bar plus d. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Right. Now it is 0. We'll put 1 here when it is 2 is 2, 3, 4, 6, 8, 10, 12, 14, 15. Okay. This sounds good, isn't it? We can directly get one octave, rolling octave. You see this and this. Then you will not get a chord. We will have this pair and we'll have this pair. Yes. So we will have octave, rolling octave. Don't make two chords. Rolling octave between 0, 2, 4, 6, 8, 10, 12, 14. Right. So this side, if you see, A bar cancel each other, B bar cancel each other here, isn't it? And this side again, when you see C and C bar are cancelling each other, I am left with D. So this is D. Now this pair between 2 and 3, it is A plus B plus C bar. And again we have a pair between 14, 15. Do you take tuitions for class 11? Okay, Rakesh, we can talk about it later in once we focus for tomorrow's exam. Yeah, I take, but again we'll talk about it later on. 14, 15, again it will be A bar plus B bar, A bar plus B bar, and again we have this side again. If you see D and D bar are cancelling each other, I'm left with C bar. So it is A bar plus B bar plus C bar. So we get F is equal to, this is D plus A plus B, D dot A plus B plus C bar dot A bar plus B bar plus C bar. And then you will draw the logic circuit. I hope that much is clear to everyone. Right, so SOP, POS, 5 marks, 5 marks. That's, again, I'm telling you, till the board examinations, do not forget this. Very important. Any further queries, let me know. Okay, good. Now you can get, as discussed in the class as well, you can get a story type question in which you have first to make the truth table. Based on the truth table, again, you will make a K map. Based on the K-map, you will draw the logic circuit, right? Based on the K-map, you will draw the logic circuit. So that is one part. I hope that should not be a problem. So you will need to define the truth table first, right? You will first make the truth table. Based upon the truth table, you will be making the K-map, and based on that K-map, again you will reduce the K-map, and then you will be using that logic circuit again to make the logic circuit. Based on the K-map, the reduced circuit will come, and based on that, you will be making the logic circuit. That will be there. Then, when we talk about from your side, if you have any query, just let type there. I will be discussing that as well. If you have any queries. Proposition logic, very good. Proposition logic. When we talk about proposition logic, again, proposition logic is a method of this Boolean algebra only. When we talk about proposition, is a different topic again. And in proposition logic, what happens that we have different propositions, right? What is the propositions? What is the proposition? Basically, if we talk about, so proposition is basically a statement which results either in true or false, right? It is a statement which results in true or false. Now, when we talk about a proposition, Tejas is a good student. Now, this can be either true or false, right? So, Tejas is a good student. It results to true or false. What is the time now? What is the time now? That is not a question which will result to a Boolean value. So that is again when we talk about that this is not a expression, this is not a proposition. So proposition is such a statement which results to true or false. Now this proposition can be either simple proposition or compound proposition. Simple proposition is a single statement. Compound proposition is a statement where there are two statements which are connected by a connectors. Now there can be different. Okay, we can have disjunction. There can be different connectors when we talk about. So there are different connectors which are used in propositions, right? There are different connectors. So the first one is disjunction, right? Disjunction. Disjunction is basically the or. It is noted by plus or this. That is disjunction. Okay. Now next, when we talk about this, after disjunction, it is conjunction. Conjunction is just like your and. This is noted by this or this, right? Then we have if conditional. If you study well, you will get good marks. So this is noted by this, right? Or it can also be noted by this, right? This is conditional. Again, we can say by conditional, if and only if. So this is biconditional. For this conjunction and disjunction, we have the same and or as we have no. For if I say conditional, for conditional it is 0 0 it will be 1, 0 1 it will be 1, 1 0 it will be 0, and 1 1 it is 1. But if I talk about biconditional what happens is 0 0 it is 1 and 1 1 it is 1, 1 0 and 0 1 it is 0. Then we have negation, that is the complement. So the negation basically, if we talk about, is noted by this or it is noted by the bar. So that is negation. So these are the basically the different. After that, again we have certain things called related to the truth table. That is contingency, tautology, and contradiction. When we talk about truth tables, again, a tautology is such a truth table or such a Boolean proposition which results one in all the conditions. That is a tautology. If a truth table returns 0 every time, it is a contradiction. And if a truth table returns a combination of 1 and 0, then it is a contingency. So you can be given a statement or a truth table to make, and then you could be asked whether it is a tautology, it is a contradiction, or it is a contingency. Then we have statements converse, inverse, and contrapositive. If there is a statement, if it is raining, then sky is not clear. If it is raining, sky is not clear. That's the statement. So I combine, if it is raining, then sky is not clear. A implies to B. If I have to find the converse, so converse of A implies to B becomes B implies to A. If sky is not clear, then it is raining. So A implies to B, its converse becomes B implies to A. Inverse. Inverse is negation of A implies to negation of B. If it is not raining, then sky is clear. That is the inverse. Now, when we talk about contrapositive, contrapositive again, negation of B implies to negation of A. If the sky is clear, then it is not raining. So this is again the proposition. Then when we talk about different laws, we have this absorption law, that is A plus AB equal to A. Involution law, A double bar equal to A. Idempotent law, A plus A equal to A and A dot A equal to A. Then complementary law, A plus A bar equal to 1 and A dot A bar equal to 0. Then commutative law, A plus B equal to B plus A dot B equal to B dot A. Associative, A plus B plus C is equal to A plus B plus C. Distributive law, A dot B plus C equal to A dot B plus A dot C. That is distributive law. De Morgan's law. De Morgan's law is A dot B bar is equal to A bar plus B bar. And again, A plus B bar is equal to A bar dot B bar. Then these are the various laws De Morgan's theorem we did. Then again, when we talk, there is duality theorem. A duality theorem states that starting from one Boolean expression, we can obtain another Boolean expression. Okay. Okay. What kind of questions can come in MCQ? Okay. Now, okay, I'll come to that. So again, when we talk about this duality theorem, it can be again starting from one Boolean expression, we can obtain another Boolean expression by changing each and to or, each or to and, 0 to 1 and 1 to 0, right? And to or to and, 1 to, right? This way we can change. Now, when we talk about this pattern of the questions, basically, like as per the curriculum, you will be getting MCQ questions. It will be 10 MCQ questions. There you can be getting questions from all, like Java also you will get. Boolean laws could be there. Anything, 4 options. Assertion reason questions, as you must have done in your class 10th also, when we talk about assertion reason based questions. So assertion reason questions may, what happens that there is one assertion and there is a reason. I say the NAND gate can be used to obtain the output of any gate. The NAND gate can be used to get the output of any gate. That is assertion. Again, I say the NAND gate always returns a high value. Now, in this case, what happened? Assertion is true, but reason is false. Right? Again, it could be the assertion is true, reason also is true, but the reason is not a correct explanation. In that case, it becomes assertion is true, reason is true, but the reason is not a correct explanation. So this way you can get, you have to think. I tell to students, even some of you who might have watched my video for class 10th, what I had done before the examination. I had done a special series for assertion reason questions. You can check my channel also. There are for class 10th, basically there is a series of assertion reason based questions from all chapters. I have taken up assertion reason based questions, so that you can refer to. In that case, again, you will be getting questions where you can access or where you can understand the different concepts, right? So when we talk about the assertion reason based questions, those assertion reason based questions, I always tell that you do not have to think with the perspective of a student. You have to think how Santosh sir has made that question, or what is going on in the mind of the question setter. that will give you a proper understanding when you talk about assertion reason questions. Okay, how the question setter is going to use that logic and what would be the correct answer that will lead you to the correct answer when you talk about the assertion reason based questions. So think twice or thrice. I always advise that when I talk about, I had told to students in class 10th also, that when we talk about our reading time, you get 15 minutes reading time, no? That reading time is used to be used in solving as many questions. The MCQ that could be clearly done, or it should be very confidently done when we talk about when in the reading time. It should be completed in this reading time only, right? You should not wait for the exam to begin, right? These questions should be solved in the this part only. Okay. This video you could refer to for the assertion reason based questions, right? This video could be referred for the assertion reason based questions. Okay. Again, when we talk about this assertion reason, okay. So you'll be getting MCQ questions. Then again, there will be few compulsory questions. So part one is of 20 marks. That's the compulsory part. And part two, again, you get in class 11th. Now they will be having two sections, section A and section B. Section A will have again three questions, 10 marks each, out of which you have to attempt any two questions, right? That can contain Boolean, means basically it will be the Boolean part or the logic circuit part that will be there, and the key map will be there. So, depending on your time, you will be attempting those questions, right? Any two has to be attempted, right? Any two questions have to be attempted from that part. And again, section B, which will be there, that will be containing programs, right? For the programming section, this will be simple program. Since we have not done much in the programs, it will be basically tell, do you take classes for AI? Yes, I take classes. No, you, no, I think you are not doing this. I take classes for AI as well. And for students, I'll again, before the AI paper, no, before the AI paper, also I'll be taking there's class once for the practice I'll be taking. Okay. And again, if you have want to have certain specific classes for AI, those students who would like to have the classes, I'm open as I told. So after the exam, we can discuss on that. Simple programs, yes, programs will be simple, Salam. I hope, Salam, you had computer in class 10. So that what we discuss, decision making, events and all, that will be there. Java programs will be of 30 marks. Five programs, 6 marks each will be there. You will get options there, internal choices will be there. Any doubts again, students? Any topic you have, let me know. Don't worry about the time. We have the revision so that you are prepared for the examination. Yes, I'll be taking revision class before AI exam. I'll let you all know. But it feels disappointing when students don't join. Like that, we have so many students, but still very few join. So that's again disappointing. How to find 12? Okay. Will we find using duality theorem? The answer. Well, if I say the statement A bar B plus AB is right? I have to find a dual of this. What I told, for obtaining a dual of an equation, change each and to or, each or to and each understand plus one. That is A bar B B plus A B bar plus one. Right? What I do, A bar plus B plus C. And to all and to all. Or to and. Dot. A plus B bar dot. Is it clear? Yeah, I hope it is clear. Okay, now, file one question. Application of Boolean algebra. Application of Boolean algebra, you need to half adder, full adder. Half adder is used to add 2 bits. Full adder adds full adder is used to add 3 bits. Yes, and then encoder and then decoder. When we talk about encoder, again encoder is used to obtain, like if I have the decimal to binary, or decoder again we get. So when we talk about this encoder and decoder, so again when we talk about this encoder and decoder part, I'll just 1 second wait. I shall not draw it, and let me share one file. Okay. So Payal, I hope you can this. This is the octal to binary encoder, right? 0 0 0 0 zeros 1 0 0 0 0 0 1, like this it is there. 0 0 0 0 0 1 it gives. So what I'm doing, see, this is here 0 0 1. So I connected this 1 to this 0 1 0. I connected this 0 1 1 this way. So this way we can get the encoder circuit. Again, when I talk about decoder, what happens? Decoder is the inverse of it, like this. 0 1 2, 0 is connected to the complement, 1 is connected to the non-complement, right? 0 0 0 all coming from the complement, 0 0 1 0 0 from the complement and 1 from the non-complement. So in this way you'll be able to get the, so encoder, decoder, multiplexer, and then half adder. The logic circuit we must have done in the class. You can copy, you can just check. Now I hope it is clear. Okay, just see then. 0 1 2 encoder and right. 3 4 5 6 7. Okay. 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. This is for the encoder. 0 1 2 3 4 5 6 7. Right. So this is the encoder circuit. Encoder is used to convert any logic to this binary format. Decoder again is there, that which is used to decode it, right? Any to binary that you can do. Sir, K map in short समझा दीजिए. ए K map को I explained in short नहीं, in full I explained. ठीक है, I'll explain it again. K map, as I told, it's used to reduce the Boolean expression. ठीक है, K map Boolean expression को reduce करने के लिए हम लोग use करते हैं. And then like if you had not watched the, you can again you can go back once after I complete the session. You can just go back, and again if you have any doubt, you can let me know. So K map में क्या करेंगे ना? We need to form groups, right? We need to form, first we'll plot it in the K map, like the box which we had seen, that we will. A bar, B bar, A bar, B, AB, and then AB bar. Here it is C bar, D bar, C bar, D, C, D, and C bar. I'm doing what SOP. Now 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now whichever the things are given, we will put the ones whichever are there, like 1, 1, 1, 1, 1, 1, 1, 0, 1, 1, 0, 0, 1, 0, 1, 1. Now I make groups. अगर 8 का ग्रुप बनेगा पहले तो विल मेक इट एन ऑक्टेट लाइक यू सी हियर आई कैन नॉट मेक एन ऑक्टेट आई कैन मेक वन क्वाड लाइक दिस क्या हो जाएगा ये बार बी बार आई कैन मेक वन क्वाड लाइक दिस इज again I can make a pair like this or better than a pair it will be I'll look for a quad this will be a quad again this will be a quad this will be a pair and I'll name it accordingly so that is basically and then we will like if I say this is a bar b bar this is c b bar again if I say b bar is common here and this side c bar so it is b bar c bar so I'll sum up all the terms that will be introducing it I hope this is clear okay map any other doubt students let me know if you have any doubt no doubts then okay all the best to all of you and if you feel like if you have any problem you can let me know you can ask me no problem all the best to all of you and wish you all get good marks so redundant group redundant group is such a group which is also member of all the means all the members are also member of any other group and in that case we will not consider that group as well. So redundant groups, if all members of a group are also members of other group, then that group will be not counted, and that group is known as a redundant group. Can you repeat the pattern of the paper? You will have MCQ questions and again some subjective questions in part 1 that is compulsory 20 marks. Again part 2 section A you will be having 3 questions K-map and all will be there. That will again you have to attempt any 2 and again section B will be there will be 5 questions. You have to attempt 7 questions will be there out of which you will have to attempting 5. ट्यूटोरियल्स में कोई लिंक काम नहीं करता है इसलिए लेट हुए क्लास ज्वाइन करने में ऐसे काम क्यों नहीं करता है that should work you could check once in your Google even if you might not have been logged in the YouTube I guess you could try sometimes if the link is not working na you can log out of the your school Gmail one and that you can so might be because others they had joined so I don't think it should be a problem anyone else with any doubt because I wanted that there should be a platform where all computer students could interact, but again, it doesn't happen. So that is there. Again, before the AI session, those of you who are in the AI, I'll be taking class session again before the AI examination. That will be there. Okay, so all the best to all of you. Doubts? I'm still there for 2-3 minutes till you say. If you have any doubts, you can let me know. Or even if you have face certain problem, you could just have my number. You can just text me as well, or you could just type it in the chat. I'll just comment. I can just respond. Okay, so all the best to all of you. Thank you. All the best. Duality theorem, as I told, using one Boolean expression, we can obtain any other Boolean expression, like changing each and to or to and, 1 to 0, and 0 to 1. Okay, thank you, thank you, thank you. All the best.